This is bellwork for Monday, January 22nd. On number 1, it's asking us to simplify negative 21w to the 5th power times u to the 2nd power over 7 times w to the 4th power times u to the 5th power. So the secret to doing these is to split them. So I'll start by just doing the negative 21 over 7. And that's going to simplify to negative 3. Then we'll do the w to the 5th over w to the 4th. And when you have exponents like this, what you do is you're really subtracting, or you're really dividing, which means for exponents we subtract. So we're going to do 5 minus 4, we'll get w to the 1st power. And then we'll do u to the 2nd over u to the 5th. And 2 minus 5 is negative 3, so that tells me it's going to be in the bottom in the denominator. So it's going to be 1 over u to the 3rd. And put all that together, we'll get negative 3 w over u to the 3rd. On number 2, it's asking us to write the equation of the line given, and they're giving us the points in function notation this time. So the thing is, these are our x values, and these are our y values. So we really just have 2 points. And we know what to do for 2 points. When we have 2 points for a line, we're trying to find the equation. We do the slope, and then we find the y-intercept. So for this one, we're going to do these 2 points. We're going to have 0 and negative 1, and 3 and negative 10. So let's find the slope first. We'll do m is equal to y2 minus y1. So we'll do negative 10 minus negative 1 over x2 minus x1, so 3 minus 0. And that's going to be negative 9 over 3, which is equal to negative 3. And then we'll go ahead and put that into our slope-intercept form equation and figure out what is the y-intercept. So we can use either one of these 2 points. I'm going to use the one where the x is 0 because that'll make it easier. So I'm going to use this one. Okay, so we'll do y, which for that equation is going to be negative 1, equals m, which is negative 3, times x, which is 0, and plus b. Okay, so this is going to cancel, and we'll get negative 1 is equal to b. Then we put all that into our slope-intercept form. We'll get y equals m, which is negative 3, x minus 1. On number 3, it's asking us, is the function linear, quadratic, or exponential? Remember last week we did this with a table, and we were doing linear and exponential. We didn't do quadratic. So this is a little bit more involved. We don't have a table, but we still have, we can make a table if we want. You just put the points into a table, if that helps you look at it better. So we have negative 2, negative 1, 0, 1, and 2. Make sure I got them all. Yep, I did. So I don't need this part. And then we have 16, 8, 4, 2, and 1. So we have to look at how is it changing each time. And it looks like it's going down. Let's see. It looks like we're reducing it by powers of 2. So on this one we're doing minus 2 to the second power, or third power. From 8 to 4, we're doing minus 2 to the second power. From 4 to 2, we're doing minus 2 to the first power. And from 1 to 2, we're doing minus 2 to the 0 power. So this is exponential. Number 4, it's asking, are the lines parallel, perpendicular, or neither? The key to this kind of question is a slope. So the key is a slope. The key is a slope. So what you do is you find the slope for the two equations. If the slope is equal for both of them, then they're parallel. If the slope or the slopes are negative reciprocals, that means you flip the fraction and one of them's negative for the other one. Then it's going to be perpendicular. And then if the slopes are neither one of those two, it's going to be neither. So we're going to have to find the slopes for both of these. And it's pretty easy. We'll just get the y by itself and see what's in front of the x. So the first one is going to be y equals negative x plus 5. On the second one, we're going to get y equals negative x minus 10. And what's in front of both of them is going to be a negative 1 for the slopes. So the slopes are the same for both. That means that they are parallel. Number 5 is asking, did Moki or Kappa weigh more at birth? And for Moki we have a table, and for Kappa we have a graph. Alright, so for Moki, the weight was at 0 weeks was 1. And for Kappa, we look on the table, at 0 it was on the 2. So it's going to be Kappa.